Hi guys, in today's video we're going to talk about solids of revolution. A solid of revolution is formed by rotating a function around either the x or y axis. All solids of revolution are three-dimensional solids that are rotationally symmetric. And the reason that we're covering solids of revolution in this topic is that we can use integration to work out the volume of the solid formed. The relevant formulas are that the volume is given by pi times the integral from a to b of x squared dy, or pi times the integral from a to b of y squared dx. And we'll take a look at where those come from very shortly. So let's take a look at an example to get started. Here we have a straight line graph, and if we imagine rotating this about the x-axis, then what's going to happen is that we're going to form circles. This thing is going to rotate around the x-axis in such a way that it actually forms a cone. Now, because the function has been rotated, this object has rotational symmetry at every point. And what it's effectively made up of is circles of varying size. So if we look at the cross-sectional area at any point, we can actually represent that as a function. The cross-sectional area of this shape at any point is given by pi y squared. It's the area of a circle where the radius at that point is the value of the function y. And given that y is in fact given as a function of x, we can write that as pi times the function of x squared. What we have now is a function that tells us the changing cross-sectional area of that solid as we move through the different values of x. But then that seems to indicate that if we add up all of the area under this area function, what we're actually doing is adding up the total volume of the shape. So we'd have that the volume equals the integral from our starting value to our final value of this area function over the various values of x. And that is the definite integral from a to b of pi times y squared dx, or pi times the definite integral from a to b of f of x squared dx. So if you have a function of the form y equals f of x, you simply square that function, integrate it across the range that you're interested in, and multiply by pi, and you'll have the volume of the solid formed by rotating it around the x-axis. Of course, we can do the same thing with rotating a function around the y-axis. In this case, though, we would be looking at the value of the x-coordinate as the radius of each circle, and we would be integrating along the length of the solid from y equals a to y equals b. So if this function was y equals 2x, we would want to rewrite it as x equals y on 2, and then we would substitute into our volume equation pi integral from our start to our finish, so let's go from 0 to 10 of this function x squared. Now we know x is y on 2, so that'll be y squared on 4 dy. And we'll have pi times y cubed on 12 from 0 to 10. And this gives us a final answer of 1000 pi on 12, or 250 pi on 3. Now, since we're measuring volume, you would have to imagine that the function would have units, that we would have the size of each circle in millimeters or centimeters or meters, kilometers, some units, and that you would then use those in your final answer. But for now, we'll just write units cubed because it is a volume and we'll have cubic units.